do to answer those all-important questions is a PhD student who was part of a scheme to help NASA with the mission to divert a particular asteroid. And Catriona McDonald joins me now. Hey, Catriona, how are you?
Hi, I'm great, thank you.
Good, good. Now, what did you do for your degree and now for your PhD?
So I studied astrophysics at university for my first degree. So I sort of trying to understand how stars work and planets and all that sort of stuff. And now I'm doing a PhD in astrophysics as well.
Amazing. You must be so smart, like so smart. Do you know what I mean? But how did you get involved with the NASA DART scheme?
Yeah, so my PhD area of research is generally about asteroids of a kind to start off with. And my supervisor sent me an email with a link to apply to this scheme called DART Borders, which was essentially an opportunity for early career researchers or PhD students to come and join in on a investigation team meeting for this DART mission. So basically I got to go and, well, I didn't get to go because travel was a bit restricted back in June when this happened, but I got to virtually go and attend a big team meeting of all of the incredible scientists at NASA working on this mission and get to learn all about it and how NASA makes a mission happen.
That's amazing. And do you know what? At the end of the day, it doesn't matter that you didn't physically get to go there. You were still involved. Do you know what I mean? You were still involved in something big. You know what I mean? You still sat round the table, as they say. But tell us more in depth about the actual NASA DART mission.
Yeah, so DART is an acronym which stands for the Double Asteroid Redirection Test. And it's essentially it is a test. It's a demonstration to prove that we would be able to, if an asteroid were to come towards Earth, and in a way that's probably going to be quite harmful to us on Earth, would we be able to hit it with a spacecraft and knock it out of the way? So DART launched this morning successfully, which is great. And it's on its way to a double asteroid. So it is a big asteroid with a slightly smaller one orbiting around it, a little bit like our moon orbits around the Earth. And when DART gets there, it's going to smack into the smaller body, which will push the smaller body slightly closer to the bigger one, and it will cause it to orbit around the bigger asteroid, which is called Didymos, quicker. And we should be able to see on Earth, we can measure how quicker it has made the smaller asteroid, which is called Dimorphos, move. And it should be able to tell us whether or not we would be able to knock an asteroid out of the way if it were to come to Earth.
This is wild. The drama. The absolute drama. I mean, it's dangerous, so that's bad, but I love it. Like, not the danger, but the excitement of the whole situation. You're basically playing baseball with a really dangerous, really big ball. Do you know what I mean? Like, let's see what happens. Yeah. This is very exciting.
But it's absolutely not dangerous to us on Earth at all. I need to say that. There's no
Start
chance
panicking,
that
everyone.
This is going to go wrong. And there's no chance that Didymos or Dimorphos is going to come to Earth as a consequence of what we're doing.
You heard it here first. Okay, you heard it here first. We're safe. We need to get that out. But is space somewhere that you would want to go one day, do you think?
Oh, that's a really tricky question. I don't think I would like to go to space.
Really?
I quite like having my feet on the ground and looking at it from a distance.
But so if somebody ever gave you the opportunity, say like they were like, oh, the astronaut got sick. You know what I mean? Like, they were like, imagine it, like, let's just take it well out of context. An astronaut got sick. We need you. Would you go?
I probably would. I mean, you can't really turn down an opportunity like that.